Good morning. This is Unlock Circuits 18EC42 Module 2 Lecture 3, that is Frequency Response of CS Amplifier uh, Exercises, that is numerical problems which we'll be taking up in this class. So first 9.1, or it is something else might be in your 5th edition book. This is according to 6th edition. So we wish to select we need to find out the values of CC1 and CC2 and CS, that is coupling capacitor and the bypass capacitor for the common source amplifier, wherein RG is given as 4.7 megohm, RD and RL equal to 15 kilo ohms, R sig equal to 100 kilo ohms, and GM equal to 1 milliampere per volt. However, we would like to have a FL as 100 hertz, and the nearest break frequency will be to this FL, the other nearest break frequency will be at least a decade lower. That means 100 hertz divided by 10, that will be 10 hertz as the other frequency. So taking up this problem, we know that FL is equal to FP2. So the second pole is the dominant pole. We have already discussed in the class that second pole is the dominant pole. Hence, FP2 is equal to FL. WP2 expression we have GM by CS, and GM is nothing but 2 pi, WP2 is nothing but 2 pi FP2, and that is equal to GM by CS. And hence, we can, readjust all this. That is, FP2 is equal to 2 pi will go on this side. So it will be GM by 2 pi CS, and that will be equal to FL. So now if I take the CS here and FL here, then I'll get the equation here. CS is equal to GM by 2 pi FL. So GM is 1 milliampere per volt. 2 pi into FL is 100, that is FP2, that will be equal to 1.6 microfarad. So CS we are able to find like this. Then we have also said that it is the other center frequencies are 1 decade lower. So FP1 is equal to FP3 is equal to FL by 10, that is equal to 10 hertz. So that gives us that WP1 formula we know, 1 by CC1 R G plus R sig, and from this we can always find WP1 will be equal to 2 pi FP1. So 2 pi I am taking this side, I am writing the expression here like this. Then I am just taking this CC1 this side and FP1 here, then you will get this equation, and I am trying to substitute there and going to get the value as 3.3 nanofarads. Then FP3, we will come to FP3 now. FP3 is again in the same way 1 by 2 pi CC2 RD plus RL. This is the formula for FP3. Really speaking, what we know is WP3 is equal to this 2 pi will not be there, 1 by CC2 RD plus RL, and FP3 will be definitely this 1 by 2 pi will get added up there. So CC2 I can take this side, FP3 again I can take this side, then I'll get the formula for CC2 like this. And you just need to substitute FP3 as 10, RD is 15, and 15, 10 to the power 3 I'm writing because these are in kilo ohms. So at the end we'll get 0.53 microfarad. So that is the example 9.1. Now we'll go to the example exercise 9.1, which says a CS amplifier has the values of CC1, CS, and CC2 as 1 microfarad, and R0 as 10 megohms, RC as 100 kilo ohms, GM as 2 milliamperes, RDRL, both of them 10 kilo ohms. We need to find AM, FP1, FP2, FP3, and FL. So what is the expression for AM? AM consists of minus of RG divided by RG plus RC into GM. RL, you can write RL dash here or RD in parallel with RL. However, small R0 is not given to us, so we need not bother about it. Over here, we will just have RD in parallel with RL. Ideally, it will be R0 in parallel with RD in parallel with RL. So RG is given as 10 meg, and Rg is 10 meg. Rsig also we are writing in meg, it is 100 kilo ohms, and that is nothing but 0.1 meg ohm. They all are in meg, so meg will cancel in the numerator and denominator. This is 2 milliampere per volt. Rd and Rl are 10 and 10 given, and that is in kilo ohms. Kilo ohm and milliampere will cancel. So we'll get here 5 into 2, 10. 10 multiplied by this value, whatever we have here, which is a little less than 1. So we'll get minus 9.9 volt per volt. FP1 formula, again, same formula, whatever we have used in the last numerical. 1 by 2 pi cc1 Rg plus Rsig, and that is equal to, we can substitute for cc1 1 microfarad, Rg is 10 meg and 0.1 meg, so meg will be 10 to the power of 6, and that will cancel with micro, and hence we'll get this factor as 0.016 hertz. Similarly, FP2 we can find, which is Gm by 2 pi Cs, that is 2 by 2 pi 1 microfarad. So this is milliampere, and this is microfarad 10 to the power of minus 6. This is 10 to the power of minus 3, and hence we'll get 318.3 hertz as the value of FP2. Now FP3 can also be found here, 1 by 2 pi cc2 Rd plus Rl. Just you need to substitute the values of cc2, Rd and Rl, you'll get 8 hertz. Out of all these three quantities, 8 hertz, 318, and the 0.016 hertz, the highest one is 318.3 hertz. And that's why, because this is the highest of all the three, we call FL. FP2 as the dominant pole, or rather P2 as the dominant pole, and FP2 as the dominant frequency, and therefore that will be equal to FL. Then coming to the example 9.3, find the midband gain AM and the upper 3 dB frequency FH of a CS amplifier fed with a signal source having an internal resistance RC equal to 100 kilo ohms. The amplifier has Rg equal to 4.7 megohm, Rd equal to Rl equal to 15 kilo ohm, Gm 1 milliampere per volt. Then we have R0 as 150 kilo ohm, CGS equal to 1 picofarad, and CGD is equal to 0.4 picofarad. So AM, again same formula, minus Rg divided by Rg plus R6, Gm RL dash. Now this RL dash we have written as R0, Rg and RL, all the three in parallel to each other, because R0 is given here, Rd and RL are also given here, so therefore we have got all the three. Say if R0 was not given, then we need not bother about this R0. So we can just substitute those values, 4.7 meg, 4.7 meg, 0.1 meg, and 1 milliampere per volt for Gm, and the RL dash value, that is 150K parallel with 115, 15 parallel with 15. All this is kilo ohms, and kilo and milli will cancel, and hence we will get the value as minus 7 volts per volt. Cin is equal to CGS plus CGD into 1 plus Gm RL dash is the formula, and you need to just substitute it. If CGS is 1 picofarad, CGD is 0.4 picofarad, then 1 plus 1 milliampere per volt, 150 into 15 into 15 kilo ohms, kilo and milli will cancel. So we'll get on the whole a value which is 4.26. Okay, 4.26. So FL will be 1 by 2 pi C in Rsig in parallel with Rg. We have found C in here, and Rsig and Rg we know, and you can just substitute over here. C in is 4.26 picofarad, 4.26 into pico is 10 to the power of minus 12, and hence we'll get FH as 382 kilohertz. Then 9.8 for the CS amplifier in the earlier example, find the value of AM and FH that results when the signal source resistance is reduced to 10 kilo ohms. So nothing big about it, only the signal source is reduced to 10 kilo ohms, that is 0.01 mega ohms. So only difference is here in the Rsig value, which is 0.01 mega ohms. So therefore this will rather increase to 7.12 again with a minus sign. Also, we can try to find out the FH value. Cn is not going to change at all because in RSIC does not come into picture as well as Cn is concerned. And the only thing, which gets affected is this RSIG, and hence we have this, and at the end we will have 3.7 megahertz. Then we come to the exercise 9.9. If it is possible, so what is that we are trying to do in the example in 9.3? What we will do is CGS will replace with a smaller value, what you call having the same CGS but smaller CGD. So we are using smaller CGD. So we need to find the maximum value of the CGD so that the FH value will become at least 1 megahertz. So if we want here now FH to be 1 megahertz, so what is the value of CGD for which the FH is equal to 1 megahertz is what is asked by keeping the same value of CGS in the earlier example. So the formula is again 1 by 2 pi Cn Rc in parallel with Rg. So Cn is the one which is changing now because it is the CGD which, what is that, uh, Cn is the one which is changing, and that is because of the CGD change. So we need to find Cn, and FH is given as 10 to the power of 6, and this whole thing is there. Cn, we can take this side, 10 to the power of 6, you can take this side, and hence we'll get this value, and that will be 1.625 picofarad. Cn formula, we know CGS plus CGD plus 1 plus GMRL dash. CGS we are keeping same. CGD is what is the new value of CGD which we need to find. 1 plus 1 into 150 in parallel with 15, in parallel with 15. All these things are there, and then you can take this 1 picofarad on this side, so it will become Cn minus 1. And this you can take in the denominator, and then we'll get the value of CGT. So Cn minus 1 divided by 1 plus 1 into 150 in parallel to 15 and 15, and you'll get this as point. So this will be 1.6254, and hence this quantity will be 0.6254 divided by 8.14, and that will give us 0.077, which is almost same as the value which is given in the solution, that is 0.08 picofarad. So with this we come to the end of the lecture today.